Unit 2, Activity 8. It is compound and continuous growth. Using fractional exponents, we have modeled growth that is described and occurring not every 1 year, but every n number of years. However, sometimes growth occurs in several times during a single year. Common example occur in finance, where savings account interest is calculated 12 times a year, meaning that's every month, or a credit card interest which is calculated 365 times during a single year, and that is 365 times meaning daily. Many quantities in nature also have a percentage growth. However, they grow even more frequently than daily. We often describe these quantities in nature by growing continuously. In this activity, you will learn two new variations of the typical y equals a times b raised to x model, one for compound growth n times during a year, and one for continuous growth. The continuous growth model also uses a special number that is represented by the letter E. Here, you will define variables in a context, interpret the meaning of constants in an exponential function's a context, use your own words to explain mathematical concepts and the connections between concepts, and show work in an organized and logical manner. You will solve problems involving compound interest and continuous growth, and model exponential situations using the base E. Solve exponential equations using logarithms, and use function notation, and use information given in symbolic and verbal form to solve problems involving exponential functions base E. And then let's start with some warm-up problems. Letter A, 6/7 divided by 5, fraction divided by a number. Remember to simplify this. So 6/7, get the reciprocal of 5, which is 1/5, and then proceed to multiplication. Then we multiply across, that is 7 times 5 is 35. Letter B, 4/2. So again, let's get the reciprocal of the denominator, 3/2, and multiply. So 4 times 3/2, 4 times 3 is 12/2, which is equal to 6. See, x divided by 1/12. So x times the reciprocal of this is 12. So x times 12 is 12x. And D, x/3/4. So that is x times the reciprocal of 3/4 is 4/3. So the answer is equal to 4x/3. Okay. Number 2, write an exponential equation that matches each of the following descriptions. Remember to always define the variables that you use. So remember, just to recall, exponential equation that's in the form of y is equal to a times b raised to x. Letter A, a supply of 1.4 billion barrels of oil was discovered, and it is being used up at a rate of 8% each month. So an exponential equation here, y is equal to A is 1.4 billion barrels times use up at the rate of 8% each month. So 1 minus 0.08. So this is a decay. So 0.92. And each month, so that is x/12, where x is the time in years and your y is barrels in billions. Letter B, in 2010, there were about 6 million people living in Arizona. In the past year, the population decreased by 0.9% and may continue to decline at this same rate. So to write the equation for this, it's going to be y is equal to, we started with 6 million in 2010, so 6, and it's a decrease by 0.9%. So let's recall decreasing, that's going to be 1 minus r, so 1 minus 0.09 is 0.991 raised to x, where x is years from 2010 and y is people in Arizona. Letter C, the US national debt was 16 billion in 1930 and it grew at a rate of 3.5% every 4 years. So our equation here, 16 billion in 1930, and as you have a growth, so increasing, so we have to use 1 plus r, so 1 plus 0.035 is 1.035x. Oops, every 4 years, so have it 4x, whereas x is years since 1930, and your y is the national debt in billions. Okay. Alright, a class discussion. There are 2 parts. Part 1, compound interest, earning interest upon interest. Number 1, for certain types of investments such as certificates of deposit, you earn interest only after many years. And let's consider this given function. F of x equal to 1000 times 1.24 to the power of x over 12. Letter A, what does 1000 tell you about the investment? That is the initial value amount invested. And what does 1.24 tell you about the investment? It has a yearly rate of 24%. And what does x over 12 tell you about the investment? That is, x is the number of years divided by 12, so meaning that is every month. So it has 12 months. And what is the investment worth after 12 years? So it's like solving for when x is equal to 12, whereas x is the number of years. So that is 1000 times 1.24 raised to 12 over 12. 12 over 12 is 1. So it's just simply 1000 times 1.24. And that is equal to 1240. How long does it take for the initial investment to double its value? So at the beginning you have $1,000. To double it, it would be 2,000. So let's say 2,000 is equal to 1,000 times 1.24 raised to x over 12. If we divide both sides by 1,000, so this is 2 is equal to 1.24 raised to x over 12. And then we can rewrite this as 2 is equal to 1.24 raised to 112 to the power of x. And then to solve for x, you can take log both sides. Or let's first simplify 1.24 raised to 1/12. That is, using your calculator, 1.24 raised to 1/12 is 1.081 the power of x. Now rewrite this in log form. So base is going to be 1.0181 log of 2 with base of 1.0181 is equal to x. And use your calculator here. So x is 38 approximately equal to 38.67 years. Okay. Now, letter F, convert the equation f of x equal to 1,000 times 1.24x over 12 in standard form. Y is equal to a times b raised to x, just like what we did here. So this is equal to 1,000 times 1.24 raised to 112 raised to x. And 1.24 raised to 112 is 1.0181 to the power of x. Okay, that is number 1. Number 2, when you save money in a bank account, the interest is added to your account more than once per year. Consider this function, f of x equal to 1,000 plus 0.24 over 12 to the power of 12x. In this situation, 24% yearly interest is divided into 12 parts. That's why it's 0.24 divided by 12, and the interest is added to your account every 1/12 of the year. That means the interest is added every month. We say that the nominal interest rate is 24%, meaning that annually is or per year, and that 24% is divided across the 12 months. So that's why 24 divided by 12 is 2% interest. And every month we can say that it's compounded monthly. Next, let's answer these questions. Letter A, what is the value of the account after 1 year and after 2 years, assuming that no more money is put in or taken out? So to answer, after 1 year, so it's like f of 1 is equal to 1,000 times 1 plus 0.24 over 12 raised to 12 times 1. Use your calculator and you will get f of 1 is 1,268.24. After 2 years, let's do the same thing, but this time it's f of 2. So 1,000, 1 plus 0.24 over 12, since it's compounded monthly, so 12 times 2. And here you'll get 1,608.44. Letter B, why is this exponent in the equation 12x and not x or x over 12? Since it mentioned that it is compounded monthly, that is 12 months in a year. How would the function change it? Instead, the interest was compounded daily. So daily meaning there are 365 days in a year. So we use that. It's going to be f of x is equal to 1,000 times 1 plus 0.24 is the nominal rate over 365 raised to, instead of 12, we use 365x. Letter B, D, convert the equation f of x equal to 1,000, 1 plus 0.24 over 12 raised to 12x in the standard form y equals a times b raised to x. So what we do is f of x is equal to, let's simplify first inside the parentheses. 0.24 over 12 is 0.02 raised to 12x. 1.02, you can rewrite this as 1.02 raised to 12 raised to x. And 1.02 raised to 12 is 1.268 raised to x. And that is the question is, what is the actual yearly interest rate? Is, yes, 26.8%. Okay, let's summarize this. If an account's interest is compounded n times per year at a nominal interest rate of R with an initial investment of P dollars, P for principal, then the value of the investment can be modeled with a function. So P times 1 plus the rate over n times, compounded n times per year, raised to n times x. That is, x represents in years annually and represents the number of times the interest is compounded per year. R represents the annual interest rate. P represents the principal amount. And f of x, that is the total amount of investment. All right, now let's have part 2, which is continuous growth and decay. Continuous exponential growth or decay means that the quantity is always changing rather than only increasing or decreasing at the end of the specific amount of time. Quantities in the natural world or quantities that change extremely fast require a different exponential equation than the ones we had used in this unit in order to model this kind of change. The equation is f of x equal to a times e to the power of rx. Okay, that is to use to model the continuous exponential change. So take note of these. R is the percent change, and always write it as a decimal. Increasing, that is when r is greater than 0. Decreasing, decay. Increasing growth, decay is when r is less than 0. And e is always approximately equal to this irrational number. So let's start with some problems here. Number 1, you invest $5,000 in a savings account that pays 7.5% annual interest, compounded continuously. Write an equation that models this situation. Remember to define your variables. So here, f of x is equal to your initial investment, $5,000 times e raised to 7.5%, that's 0.075x, is compounded continuously. So let's define our variables. X is the time in years, and your f of x is the total amount of investment. So, like letter B, find the value of the account after 5 years. So let's use this equation here. So meaning we want to solve for f of 5. So 5,000 times e to the power of 0.075 times 5. Use your calculator here, and it's going to be 7,274.96. What was the total interest you earned in those 5 years? So since you got 7,274.96 and your initial amount was 5,000 initial investment, so all you have to do is subtract this and 5,000. And the total interest you earn in those 5 years, that is 2,274.96. What was the total percent change in the account after those 5 years? Total percent change, that is equal to the total interest over the initial amount, which is BCAT 2,274.96 over 5,000, and multiply this by 100%. So what was the total percent change? It would be 45, approximately equal to 45.5%. How long will it take for your individual investment to double? So your initial investment was 5,000. To double it, it would be 10,000, right? So let's use e to the power of 0.075x, then solve for x. So if we divide both sides by 5,000, now 10,000 over 5 is equal to 2. And to isolate x, remember natural log both sides. ln 2 is equal to ln of e raised to 0.075x, and I'll continue it here. As ln 2 is equal to 0.075 of x, and then divide both sides by 0.075, so that x is equal to approximately equal to 9.24 years. Okay. Next, convert this equation from part A into a standard form y is equal to ab to the power of x. So again, we have f of x is equal to 5,000 with the initial amount, e to the power of 0.075x. So you can rewrite this as 5,000 times e raised to 0.075 to the power of x. And e to the power of 0.075 is actually equal to 1.0779 to the power of x. And what is the actual yearly interest rate? So that is 7.79%. Okay. Next, number 2. The function f of x is equal to 12.3 e raised to 0.095x models the population of a city in thousands as a function of x, the number of years since the city was incorporated in 1910. Use this function to determine when the population reached 1 million. Alright. And remember, this is in thousands, so 1 million over 1,000 would be 1,000. So it's equal to 12.3 e raised to 0.095x, and then solve for x. We divide first by 12.3. 1,000 over 12.3 is 81.30 e raised to 0.095x, and then remember ln both sides so that it is ln of 81.30 ln e to the power of 0.095x is now equal to 0.095x. And then now divide 0.095 so that x is approximately equal to 46.30 years. So when the population reached 1 million. So we started in 1910. So it's like 1910 plus 46.30. So that is like approximately 1956 to 57. According to the function, what is the continuous growth rate of the population? So we have that as 0.095, so meaning that is 9.5%. Then next, convert that given function into standard y is equal to b to the power of x to find the actual yearly growth rate. So y is equal to again given 12.3 e to the power 0.095 x. So what we do here, to the power of x. E to the power of 0.095 is actually 1.0997 raised to x. So we talk about the actual yearly growth from here is, we have 0.0997. if we subtract this from 1, so that times 100%, that is 9.97%, or almost 10%. Number 3, radioactive substance decays continuously at a rate of 15% each week. How much of a 750 sample remains after a year? So here we have y is equal to 750 e, since it's decay, so we're going to use negative 0.15x. So y is equal to, after 1 year, so times 1. So use your calculator here. You should get 645.53. Then letter B, what is the half-life of this radioactive substance? Half-life 750 is 375. And if you divide both sides by 750, so we have here 0.5, and then ln of 0.5 equals ln of e is negative 0.15x. So this is now ln of 0.5 is equal to e to the negative 0.15x. Oops, sorry. Ln e to the power of negative 0.15x is just simply negative 0.15x. Sorry, Then now we divide both sides by negative 0.15, so that x is approximately equal to 4.62 years. Okay, and that's it for this section, activity 8. If you have any questions, let me know. Thank you.